come from? Nowhere but up there.
The source of the rock fall was a section of the cliff no more than 100 feet across. A small area that became the celebrated Burgess Shale Quarry. Walcott, often aided by his own family, eventually extracted over 60,000 fossils. And since Walcott, a further 100,000 have been excavated from this uniquely rich cliff face.
Quarrying the rocks out of the mountain requires a tremendous amount of work, a lot of back-breaking labor, but it's also extremely exciting because every time you split open a rock, you never know what you're going to find. Most of the time you find nothing, but every once in a while you find a new animal, one that's never been seen before, one that's been revealed for the first time in 500 million years.
The thousands of fossils found in the Burgess Shale revealed that starting 500 million years ago, life exploded with staggering diversity and complexity.
The preservation of these fossils is actually incredible in that they're actually preserved in 3 dimensions. You can excavate through the fossils themselves, see the internal organs, remove the organs, see the digestive tract. This is fantastic preservation. Oh, look, it's starting to crack, and there goes a piece. What we have here is an actual Anomalocaris. These guys were up to 1 meter in length. That actually made them the T-Rex of the Cambrian.
In the Cambrian seas, the oxygen-rich shallow waters were teeming with complex organisms. And creatures were feeding not just on plants, but on each other.
Cambrian is actually one of the most special times in the history of life. We see more different types of animals than we see in the rest of the entire history of life on Earth.
From this time onwards, with the biological arms race driving their evolution, creatures would become increasingly complex with the development of hard shells, skeletons, eyes, and teeth. Modern animals had arrived on Earth. The high level of oxygen that had triggered this explosion of life in the seas was also making a final modification to the atmosphere. Over the next 100 million years, oxygen reached today's high levels. A level dense enough to allow an ozone layer to form in the upper atmosphere. This layer was to free life forms from the oceans. Previously, powerful ultraviolet light would destroy any organism not protected by the water. Now, the ozone layer would act as a UV shield. "400 million years ago, the Earth is more than 4 billion years old. Over the next 100 million years, the continents would once again converge. And this time, thanks to the ozone shield, life was free to leave the oceans and conquer the land. Planet Earth had become a world of tropical swamps." South Georgia, USA, the Okefenokee Swamp.
The Okefenokee is believed to be what we would call an analog, a modern analog, or an environment that's very similar to the wetlands that existed on Earth in the past.
Fred Rich is an expert on prehistoric swampland. Geologists like him believe that this freshwater swamp closely mimics the surface of the continents 300 million years ago, in a period known as the Carboniferous.
The Carboniferous was an unusual time because it was the first period in Earth history when large plants occupied Earth's surface, 40, 50, 70 feet high. that grew in dense groves and produced a vast forest canopy in a steamy, tropical jungle atmosphere that was something entirely new on the face of the Earth.
This dense tropical swampland would dominate the Earth for the next 60 million years. The evidence is present on all of today's continents in the form of coal. The coal we use for fuel was formed from millions of years' worth of accumulated plant matter, most of which existed less than 300 million years ago. And it formed because of the unique way freshwater swamps decompose.
Okefenokee is derived from a Native American word that means land of the trembling earth. It's not very easy to walk through the swamp because the subsurface is soggy plant remains.
The fresh water prevents the vegetation from decaying, allowing huge amounts to build up over time.
Beneath me is not the regular sort of soil that you would have in your backyard. The soil that you see here is the plant material that accumulated last year or perhaps 5 years ago. It's leaves, stems, twigs. There's still a good bit of water in this, but if we put this under a tremendous amount of pressure and add some heat by covering over with layers of rock and leaving it in the ground for millions of years, eventually it will change to this. This is a piece of bituminous coal, and it's on the order of 200 million years old.
As the dead plants were transformed to coal on land, the shallow waters surrounding the continents were preserving millions of generations of dead marine organisms that would become our other major fossil fuels: oil and gas. Every year, mankind mines almost 5,000 megatons of coal, 30 billion barrels of oil, and 3,000 billion cubic meters of gas. This fertile period of Earth history has given us much of the energy we use today. Without it, the Industrial Revolution may never have happened. Plants were not alone in making a new life on the land 300 million years ago. As time went on, first enormous insects, then ambitious amphibians, and finally, early reptilians left the seas to take their first steps on the muddy shorelines. The U.S. East Coast back then would have teemed with monsters: 3-foot millipedes on land, 2-foot dragonflies in the air, and proto-alligators patrolling the nearby waters. 250 million years ago. For hundreds of millions of years, life on the surface had faced numerous challenges to its survival, but nothing on the scale of what was about to happen. In what would one day become Siberia, the Earth's crust became a volcanic morass. The cause was a rare mantle plume eruption. No one knows for sure why they occur, but occasionally, huge masses of hot mantle from deep within the Earth surge upwards, melting and smashing the crust above. The eruptions continued for over 1 million years. They spewed out over 1 million cubic miles of molten rock, enough to bury the modern USA in a layer over 1,000 feet deep. Clouds of poisonous gases spread out and shrouded